All right, so we're going to keep working on chapter 8 here. So we are going to continue working on sampling distributions, but now we're going to look at proportions. So we will first discuss how we find the sampling distribution of the proportion and then conduct some probability questions. First up is describing the sampling distribution of a sample proportion. Suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. The sample proportion, denoted as p hat, is given by x over n, where x is the number of individuals in the sample with a specified characteristic. N, of course, is then your total sample. So it's just giving me a fraction of how many out of how many total have a certain characteristic, which we can then translate into a decimal and or a percent. The sampling proportion p hat is a statistic that can be used to estimate the entire population proportion p. So we've kind of done this before. We're going to do this again here. The Harris poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether the individuals planned to work while on summer vacation. Of those surveyed, 552 indicated that they plan to work while on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. Okay, so we're just going to follow the formula to find our p hat by taking the number of what we want, which is 552, over our total 1,200. And then we can translate that into a decimal. So take 552 divided by 1,200 and you get 0.46. All right, so what that means is that our estimate, according to this sample specifically, about 46% of adult Americans who vacation during the summer plan to work while on vacation. So based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for samples of size 10, 25, and 60. Okay, so what we're going to do now is the original information here, that's 76%, is when we compile all Americans together. So what we're going to do is now we're going to take samples of size 10, repeat that so many times, figure out of 10, how many each time believe moral values are getting worse. And then we'll do that again, pull samples of 25, ask the same question to each group of 25, and then we're going to repeat that with 60. What we have here is just a start of the sample here, just letting you know that 1 stands for a success, 0 stands for a failure. So 1 is, yes, they believe the moral is going down. No would be the 0. So then what they do, add them all up, 1, 2, 3, 4, 5, 6, 7, 7 out of 10 is 0.7. And then they redo this for so many samples of size 10. And we got all these different sample proportions over here. So then, like before, when we do with means, we took that final column and we graphed all of that information. So here we go. Our distribution here is, I would say, not quite normal here. It looks like our peak is over here and we've got a lot more to this side. So this is skewed left, which it does say right here. Notice the shape of the distribution is skewed to the left. The mean of 2,000 sample proportions is 0.76. Our standard deviation is 0.136. And notice that the mean of the sample proportions, so this Matches the mean that we have of the normal curve that is drawn here, 0.76. Also matches what we started with back here, 76%. Okay, so we're going to repeat the process with samples of 25 and see how the graph changes. Here are 2,000 samples of 25 graphed together. Again, you can still see it is skewed. Here's kind of the highest bar. And if I count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So still skewed. I would say not as skewed as back here, because this has 2 to this side. This has 1, 2, 3, 4, 5, more than double. We're getting closer to a normal approximation here. Notice again that this was our original proportion, and our mean here, the peak of our normal curve, is also at that 0.76. However, in this graph, the standard deviation is even smaller at 0.086. And that should make sense because we discussed that with the means, that anytime you increase your sample size, your standard deviation is going to decrease because you're dividing by your sample size. And when you divide by a larger number, your result is going to get smaller. All right, then lastly, we take samples of size 60. So I pick 60 people and I survey them. I pick another 60 people and survey them. I do that 2,000 times and then graph the information here. And once again, the mean is 0.76 and their standard deviation is even smaller than it was on the previous slide. So basically, same stuff is happening with proportions as it did with means. The shape, as the size of the sample increases, the shape becomes more normal. Okay, the center, the mean of the distribution of the sample proportion is equal to the population proportion. So just like the mean of the sampling distribution equaled the mean of the population. And then the spread or the standard deviation is going to decrease as the sample size increases. So same exact things that happens with means also happen over here at proportions. So when we are doing a sampling distribution for p hat, for a simple random sample of size n given a population proportion p, the shape of the sampling distribution will be approximately normal if this equation that we calculate here, n times p times the quantity 1 minus p, gives me a value greater than or equal to 10. The mean or mu p hat of the sampling distribution is going to be equivalent to the population proportion. And then the standard deviation of the sampling distribution is going to be found by using the formula here. The square root of p times the quantity 1 minus p all over n. Suppose the proportion of Americans who believe that the state of moral values in the United States is getting worse is at 0.76. So we're going to use that same piece of information that we had before. We're going to obtain that simple random sample of size 60. And we are going to describe the sampling distribution. The United States has over 300 million people. So a sample of size 60 is going to be less than 5% of the population. So that is one thing we always check. And then the second thing is to check this formula here, n times p, open parentheses, 1 minus p. So give me a value greater than or equal to 10. If I do not set aside this equation, I cannot say that we are approximately normal. So n is 60, p is 0.76, and we just use our calculator here. I get 10.944, which is clearly bigger than 10. So we can say we are approximately normal. And we can continue on with the process. Okay. We know that our mu p here is 0.76 because the mean of the sample is equivalent to our population proportion. And then, so here's 1, here's 2. And then step 3 is to get the standard deviation. And we're going to use our formula here. P is 0.76. So 0.76 times the quantity 1 minus 0.76, all divided by 60. And then take that answer, you're going to square root it. And this matches what we had a few slides back. Okay, so just remember, anytime you describe the sampling distribution, 3 things need to happen. 1, it should be approximately normal, and check that if you need to. 2, list the mean, and 3, calculate standard deviation. Next one is then, once we've done that, how do we compute probabilities? Questions from the sampling distribution. So, according to the National Center for Health Statistics, 15% of all Americans have trouble hearing. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? So this is what we know to be true of our population proportion here. This is our sample size. Data was obtained by random sampling, says that here. And we know there are 300 million people in the United States. So clearly 120 is less than 5% of the population. We have a very, very small percentage of our population here. Next, we are going to calculate our NP times 1 minus P to make sure that we are greater than or equal to 10, so that we can use our normal curve here. So N is 120 times P, 0.15, times the quantity 1 minus 0.15, gives me the value 15.3, which is clearly bigger than 10. So we have approximately normal. Okay, we know that our P is 0.15. So moving on, our mu P is 0.15. And then third, we calculate our standard deviation. So take 0.15 times the quantity 1 minus 0.15 divided by 120. I'm going to get that entire result, and I'm going to square. We get 0.032596. Again, like before, when you calculate a standard deviation, round to as many decimals as possible, just because the more decimals you have, the more accurate your results are going to be when we calculate the probability question. All right, so we want to know the probability that in that random sample of 120, we get a result at most 12%, also known as less than or equal to 12%. So we want to find the probability that our proportion, sample proportion, p hat, is less than 0.12. And we are going to do that by using our mean here of 0.15 and our standard deviation of 0.032596. Okay, so just to give you, again, that visual here, 0.15 is the middle. We graph 0.12, and we want to be less than that. So our goal is to use StatCrunch then to help us get that result. So I will go to stat calculators, normal. Our mean is 0.15 on my standard deviation, 0.032596. And we want to test less than 0.12. Okay, so my answer here is 0.17869. That's going to round that up. So 1787 is what I got. And we'll see on the next slide here if it matches. So if we use technology, we find the area to the left is 0.1787, exactly what I got here. Okay, so what does that mean? That means the probability that a random sample of size 120 Americans resulting in at most 12% having hearing trouble is approximately 8.18. So if I were to take a sample of 120 people and figure out how many or the proportion of them that have hearing loss, that would happen in about 18% of them, okay? Or about 18 out of 100 random samples would have this happen. Suppose that a random sample of 120 Americans, so working with that same sample size here, so we're still working with that same proportion, 0.15 is our mean, and our standard deviation was that 0.03 number that we had there, 0.032596. So supposing that random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? So we have 26 out of 120. So in this case, they gave me the total number, or sorry, the number with a characteristic out of the total. They didn't give it to me in decimal form. So I have to be careful to make sure I know that. I can't just type in, hey, my test question is, I want to test the probability that I have less than 26 people. That doesn't work because everything we're doing here is in terms of proportions. So this must also be listed as a proportion. We're testing the probability proportion is less than this. 26 out of 120 is what we are testing. And you can see that there. So we want to know if obtaining a sample proportion of 0.217 from that population is going to be unusual. What we're going to do is we're going to compute this value here. And the reason we're going, sorry, I wrote a less than symbol here. But 0.217 is greater than our sample proportion. So we are testing greater than. All right, so 0.217 is to the right of our mean of 0.15. So we want to find the probability of getting this result, because if it's unusual, then we have unusual results. Let me open my stat crunch again here. So we are testing, and you can type in the actual fraction, 26 out of 120. Stat crunch will let you do that. You can type in the fraction version, or you can type in the decimal version. It doesn't matter. Oops, I forgot to change my symbol. There we go. All right, so 0.0204. I will show you that is the same answer we got here. Oh, they got a different. All right, so theirs is slightly different because they rounded. So let's look at the difference here. I had 0.0204 using 26 out of 120. If I use their decimal, let's see if we use their rounded version of 26 out of 120. Yeah, so 26 out of 120 is not, it's a repeating decimal here. So it's 0.216666 repeating. So they rounded to 0.217, which is why if you do this, you're going to get a slightly different answer than if you use the original form of 26 out of 120. This one's going to be slightly more accurate because it didn't round the decimal here. I usually default to this method, but either one is going to be okay. Again, there's always a little bit of leeway here in StatCrunch when you're working with it, or in your homework in Pearson. So it will accept either of these. This means about 2 samples in 100, so 0.02 is 2 100ths, 2 100ths, 2 out of 100.
So this means if I were to repeat this process 100 times, only 2 of those times would we expect a value of hearing loss this high to occur. Since this value is only 2% and below the 5% threshold, we can say it is unusual.
Two conclusions we could make. The population proportion of Americans with hearing trouble who regularly listen to music using headphones is 0.15, and we just happened to get a higher proportion. Or maybe the proportion of Americans with hearing trouble from those that listen to music using headphones regularly, maybe their value is actually more than 0.15. So because we've added a different stipulation here of they listen to music through headphones regularly, maybe that has impacted their hearing more than just the average person. That could be something you could research into. It does say here the second conclusion is likely more reasonable, just because usually the more you are around loud noises or using headphones, it has been shown to decrease your ability to hear. So according to the Center for Disease Control and Prevention, 18.8% of school-age children aged 6 to 11 were overweight in 2004. In a random sample of 90 school-age children 6 to 11 years old, what's the probability that at least 19% are overweight? Okay, so a few things we gotta check. We have our P of 0.188. So remember that 18% is 18.8 out of 100. So turn it into a decimal. And our N is 90. So NP, 1 minus P should be greater than 10. So 90 times 0.188, open parentheses, 1 minus 0.188. We got to get that answer. So again, just open a calculator. 90 times 0.188 times 1 minus 0.188. And I get 13.739, which is bigger than 10. So we are approximately normal. The mean of our sample is equivalent to our proportion, 0.188. And I need to calculate my standard deviation. So that's going to be the square root of P times 1 minus P all over N. So P, 0.188 times 1 minus 0.188 all over sample size 90. And then I'm going to square root that. So again, grab a calculator. 0.188 times 1 minus 0.188 all over 90. And then square root your answer. I have 0.0412. All right, so then we want to check now, what is the probability that our sample proportion is at least 19%? So that means greater than or equal to 0.19. Oh, we'll open my StatCrims here. And I'm going to shrink it down a little bit here just so I can see everything that I need to see. 0.188, standard deviation 0.0412. We want to test greater than 0.19. Okay, so the answer I got for this one is 0.4806. So pretty common. Remember that our entire proportion is 18.8%. So to get a value of 19% isn't going to be too far off in our sample here. And we see that. All right, so let's do the second question here. Suppose again, we're working with a random sample of 90 school-age children 6 to 11 years old, resulted in 24 being overweight. What might we conclude? Okay, so we want to test the probability that our proportion is 24 out of 90. So before I can figure out here, I got to figure out, is that bigger or smaller than what I have? So 24 out of 90 is 0.267. So this is a high percentage. So this is about 26.7%. So is this percentage really high above here? Is that unusual? I'm going to go back to StatCrunch here. I'm going to change my symbol. Nope, keep it as greater than. That's right. And we have 24 out of 90. Again, I will always type the original fraction here so that I'm not rounding. Okay, so the probability of getting that answer is 0.0281. So what can we conclude about that? Well, 0.0281 is smaller than 0.05. So this result is unusual. Okay, I would not expect, if I were just to randomly grab 90 school-aged children aged 6 to 11 years old, to have 26.7% of them be overweight. That would be unusual. My proportion, according to my study, is 18.8%. So if I pull a sample, I should be closer to that. It's more likely that I would be closer to that value than farther away from it. The proportion of the human population that is left-handed is 0.12. Mensa is an organization of high IQ individuals, meaning that they have an IQ at the 98th percentile or higher. So these are the top, like 3%, 98, 99, 100%. They are the top 2% of people in terms of their intelligence. In a random sample of 150 members of Mensa, it was found that 30 were left-handed. What is the probability of obtaining a random sample of 30 or more left-handers in a random sample of 150 individuals, assuming that the population proportion of left-handers is 0.12? All right, so lots of things going on here again. So let's write what we got. Our overall population proportion is 0.12. Our sample is 150 total. That's our sample size. And what we found is 30 out of 150 are left-handed. So what we're going to do is we're going to figure out, how does this value compare to the overall population? Is there something different with Mensa individuals and left-handed proportions? Let's take a look. So first, we're going to do NP times 1 minus P and make sure that that is greater than or equal to 10. So 150 times 0.12 times 1 minus 0.12. So grab your calculator, 150 times 0.12 times 1 minus 0.12. And I got 15.84, clearly greater than 10. So we can use our normal approximation here, our normal curve. We're going to use a mean of 0.12 because that is our population proportion. And we need to calculate our standard deviation, doing the square root of P, 1 minus P all over N. So P, 0.12, 1 minus 0.12 all over 150, and then all square rooted. So again, just grab a calculator to get that value. I got 0.02653. Just to show you here what you can do really quickly, especially if you're using an online calculator like Desmos. So let me just do this quick. I'm going to open up the calculator. Okay, so let's say I want to do the square root of 0.12 open parentheses, 1 minus 0.12 all over 150. Okay, what I can do in here, right click, copy. Right click, paste. There it is. So this then allows me to not have to round and makes it even more accurate. All right, our mean is 0.12. What we got to do is we got to figure out, where does this value fall? 30 out of 150, 3 out of 15. I think that's 1/5. I want to say that's 20% here. So you can check 30 out of 150, my bad, 0.20. Okay, so we are seeing here 20% of my men's people were left-handed. So what is the probability of getting that or more? So what is the probability that our sample proportion would be greater than that 30 out of 150? So that's what we're testing. Okay, so pull my stack crunch back up. We want greater than 30 out of 150. And it doesn't even show on my graph. I got 0.0013. Okay, so this is clearly unusual. Well, what does it suggest? Well, what it's showing me here is there is clearly a higher percent of left-handed people in the Mensa organization compared to the general population. So there is some sort of relationship here with really, really smart people having a slightly higher chance of being left-handed. All right, so that is the end of chapter 8 here. So remember to do your lecture questions and your StatCrunch practice and your Pearson homework. If you need extra examples or need anything in the meantime, don't hesitate to reach out to me via email and I will get back to you as soon as I can. All right, see you in the next chapter.